said they couldn't make it. That's why today I'm going to give a talk about this work. This work has been done about tracking, and actually what we can see here, we have a result of 4 tracking algorithms working on, tested on Oxford dataset. And what we can see first, it's not easy to evaluate which actually tracking algorithm is the best. This is actually the problem. First, because we cannot compare having 2 algorithms, which one performs better. And second, if you want to tune particular algorithm, we cannot find the optimal parameters because we don't know how to measure them, right? In tracking in general, the main issue of problems is, of course, the false positives, false negatives, and ID switches. And we have many metrics to compare tracking algorithms, right? Most of you know one of the most popular, it's the MOTA score, multi-object tracking accuracy. And this one was, as for now, I think one of the main measures to compare to tracking algorithms. Interestingly, they found the algorithm, very dumb algorithm, I would say, tracking algorithm, which works in following. First, you run the detector, you start tracking, and you terminate the tracking immediately, right? Then it means that you have a number of tracklets which is equal to the number of detections. And this dumb, they call it now algorithm. Interestingly, when you look at that, it performs quite well in the terms of the most popular measure, MOTA, right, which is suppressing. In general, what they came off, the main idea is that for single actually tracking algorithm, when you have a single object, you want to track it, the measure is obvious. You want to have a tracker which tracks the object as long as possible. And the result, they came with the measure which is called mean time between failures, which they want to just see how long the tracker can perform without making a failure. Either it will be ID switch or swap ID or a false positive or false negative. Here they actually show the probability distribution of making no error. On the left is a cumulative measure where they compare what is the probability of not making error for a particular number of frames. You have a number of frames on the horizontal axis. And you can see that yellow algorithm performs the best. Surprisingly, actually the yellow algorithm is the oldest one from 2009 and has the lowest MOTA score. It seems that by introducing MOTA score, the researchers tend to create the errorless tracklets shorter. It means that actually we are doing something opposite. We are creating trackers which are working for the shorter time. Yeah, this trend actually is very surprising, and if you want to hear about more details about the I would say properties of the given measure, please see the poster A7. Thank you.